Hi, everyone. My name's Kieran Gill. I'm one of the customer advocacy managers here at Autodesk, and welcome to this Fusion 360 webinar. Today, we're going to be talking about how to optimize your cycle time with toolpath modifications. Let's start off. The agenda today really is going to focus on a few things. We're first going to have a bit of an introduction about me, what I've done, where I've been, and what I'm doing now. We'll then kind of touch on, as a broad overarching theme, on why the extensions exist. We'll then kind of jump a level deeper and have a look at the machining extension under a magnifying glass and compare the core offering to that offered in the machining extension. We'll then take another level deeper. So think of this almost like Inception, really, a level within a level within a level. And we'll look at kind of toolpaths. And a single reason to upgrade, really, in my opinion, is toolpath modifications. And it's really my job today to convince you why I think that toolpath modifications on its own is a good enough reason for you to part with your cash and upgrade to the machining extension. We'll then kind of focus on the summary of what we've seen. And then we'll also kind of talk about how you can go about getting access to the Fusion 360 machining extension. Okay, so without further ado, a little bit about me. I graduated from Oxford Brookes with my Bachelor's of Sciences in Mechanical Engineering. My early career really involved machining a lot of dental implants and prosthetics on various CNC machines and routers. And in 2011, I joined Delcam as part of the international support team. And then following that, in 2014, Delcam got acquired by Autodesk, and I then joined the customer engagement organization and the wider Fusion 360 team. And I'm now in my 10th year at Autodesk. So yeah, I've been here for a while. Okay, so let's talk about the extensions in general. Remember, we spoke about first covering the broad overarching theme of why the extensions were created. And really, the extensions were created for three different reasons. One, really to extend your platform by eliminating some of those disconnected tools and costly deployment overheads in your process, in your business, by extending your workflows and specialized technologies that come all in one platform. Number two, the extensions were really created to simplify your manufacturing processes. The extensions provide you with improved operational efficiency, with automated and optimized workflows across the various teams in your organization, which help to increase your manufacturing throughput and reduce the time it takes you to get your product to market. And lastly, really, the extensions aim to make innovation easier. They allow access to new capabilities that remove non-value added processes and enhance collaboration for easier development of smarter products. Okay, so again, another level deeper. And let's now focus specifically on the machining extension and why that was created. And again, we have three salient points. The first of those is really it was created to simplify and automate CAM programming by automating your CNC machine workflows, reducing the time it takes to program parts, remove those repetitive tasks, and ultimately reduce the human error. Number two, it was created to reduce cycle times with the specialist technologies that improves your CNC machines and the utilization of those machines. And lastly, really, the machining extension really exists to create better parts by unlocking advanced machining strategies to improve the performance of your CNC machines. And we know that better surface finish with less manual finishing time equals better components. So let's kind of jump into the core offering, and that found in the machining extension. So on the left-hand side, you'll see the current functionality in the core offering. And you'll see on the right-hand side, the machining extension functionality. Now, a number of my colleagues, including myself, have done a number of webinars already that some of you may have already attended. So we've covered things like 3- and 5-axis Steve and Shello, 4-axis rotary strategies, some various drilling and automated drilling tips and techniques. And then we've also covered some various inspection as well. Those are freely available online as well. So go and have a look at those if you haven't already seen them. But today, really, the focus is going to be on toolpath modifications on their own. Okay, so let's jump in. Now, I'm condensing about 30 minutes of content into about 12 minutes. So if it feels rushed, it is. But if we have any follow-up questions, then let's pick them up at the end. Feel free to put them in the chat. I do have my colleague Dylan Smith online as well to kind of help answer some of those questions. But if he can't answer them, then we'll kind of pick them up at the end as well. So why do we have toolpath modifications? Toolpath modifications work on both 2D and 3D toolpaths. It offers a deep level of control to make sure you're removing air cutting, reducing cycle time, and ultimately saving money. And I'd like to show you some of those examples now. So on the screen, inside of Fusion, we have a 2D style strategy. Now I'm just going to go ahead and I'm going to duplicate the strategy so we can see the before and the after. Now, this particular part presents a unique opportunity to use toolpath modifications to avoid some of the air cutting moves, as you can see here on the screen. We can simply go to that toolpath modification, select the feature we want to limit the toolpath to, and limit the toolpath. Now, the real power here is that the face selection we've selected is associative to the model, meaning that if the design changes, then the trim toolpath will also reflect that update change. A change made somewhere is a change made everywhere. And we want to make sure that we are consuming that intent of the user so that when they apply a trim to a toolpath, or when they apply a trim or a change in model design, that trim is reflected as well to consume that change. Let's now have a look at our next example. This is an example of a headlight mold for an automobile. And what we want to do is have a look at this parallel strategy. Again, let's go ahead and zoom into that. Now, I'm just going to go ahead and duplicate this strategy, just so we've got something to compare against. Now, there are a number of issues with this parallel strategy. One, it's really kind of not adhering to my contact point boundaries. And what this means is that the tool is diving down vertical walls, which could damage the tool, damage the part, and even worse, permanently damage the machine tool. Now, in some circumstances, we can try to overcome this by editing the strategy to include touch and avoid surfaces, but this doesn't always give us an acceptable result and can often result in lengthy delays in surface selection and calculation time. Now, toolpath editing aims to make this process significantly more efficient. We can use the toolpath editing to simply create polygon selections around our areas that we want to trim. And once we've done that, we can simply click on OK. Now, the bit that you need to remember here is that the toolpath is not being updated or recalculated in its entirety. Only the leads and links for the areas that I've trimmed get recalculated. Now, as I zoom out, you can see this is quite a large toolpath. Now, you can saw how quickly that updated as part of the trimming process. Let's have a look at that original strategy and compare that to the newly modified and trimmed version. This simply means we get a better surface on our parts, we have more efficient programming, and we have less manual finishing to do afterwards, which results in better quality parts. Let's have a look at this next example. On the screen, we've got a bracket with 16 different lugs. And what we can see on each side is, we've got 8 on each side. So we've got 4 on each, we've got 8 altogether, 4 on each side. And what we want to do is we want to start to machine some of these lugs. However, I've created a bit of geometry to help me out. Let's zoom into 2 of those lugs, and I've created a bit of geometry to help me machine some of these lugs. Now, as you can see, if I just turn off that geometry, what I'd like to do is have the tool come over the side and not roll around the edges of this part to create a bevel or even a rounded finish on the end of these lugs. I've created a toolpath which kind of just goes across both lugs. But unfortunately, if I turn these leads and links, we can see a number of inefficiencies here on the part, i.e. some air cutting moves. Using the toolpath trimming functionality, we can simply go ahead and sketch the areas that we don't need really nice and quickly. And we can also go and manipulate these points as well if we wanted to go and further change or edit any of these points. So again, what I'm going to go and do is accept this and select on OK. And we can see the toolpath again being modified and trimmed according to the selection we've applied. Now, I'm just going to go ahead and duplicate this toolpath, And I'm going to go ahead and just remove some of those modifications I've just created because we want to compare the original versus the modified version. So let's have a look at the original machining time. The original machining time for this toolpath was around 18:45, so 18 minutes 45 seconds. The modified version of this toolpath is now just over 14 minutes. Now, when we think about this in larger terms, so when we have a look at this part as a whole, we're looking at a multitude of these lugs across the part. So we're saving roughly about 16 minutes on this part. And if you think about a batch run of between 20 and 50 parts, this is saving you hours of machining time, hours of programming time, and allows the operator to go and do other things and be more productive, vis-a-vis make more money. So a really powerful enhancement here to reducing machining and cycle time. Okay, let's have a look at how we can utilize toolpath trimming to benefit multiple toolpath strategies. So on the screen, we've got a mold tool of a bike mud guard. And on the screen, we've got two toolpaths. One is a pencil and the other is a steep and shallow style strategy. Now, the pencil style strategy is really good because it goes into those radii areas and allows us to clear out those radii areas where material could still exist. But then we've also got the steep and shallow strategy to machine some of those vertical walls or the vertical aspect of the mold. Now, as we start to kind of zoom in and we have a look at that pencil style strategy, the pencil style strategy, unfortunately, as it's coming down these vertical walls, starts to fragment. And this is not very good because the tool going down a vertical wall again could damage the part, end up with a poor quality surface finish, and invariably damage not only the tool, but also the machine. Using toolpath trimming, we can quite easily go and trim out some of this toolpath that has been fragmented. And we end up with a really nice looking pencil style trace toolpath. Again, let's now have a look at the steep and shallow strategy. Here we can see that steep and shallow strategy, and I can go again and place a selection boundary around the portion of the toolpath I want. And in this instance, I'm going to select the inside of the steep and shallow strategy and keep that. Again, it's worth noting that the toolpath itself is not being recalculated, but only the area that I've asked to be trimmed is being recalculated. So let's zoom out now and let's go a little bit closer. And we can see a really nice example of where we're using the steep and shallow strategy with toolpath modifications to streamline our programming, but also use that on multiple different strategies to make sure we end up with a really nice surface finish and a good quality part. This is what I call a knife and fork of basically two different style strategies using toolpath modifications. Okay, and then the penultimate example of this really is kind of looking at how we can limit some of the functionality that we've got inside of things like steep and shallow, so that we're not duplicating work and we're making our lives easier. So for example, on the screen, we've got a steep and shallow strategy. It's a really complex and kind of tightly woven strategy on this particular part with kind of small step overs. The last thing we want to do is, and this particular toolpath is machining with a ball nose tool. Now, there are some flats on this particular part. So what we want to do is limit the toolpath to not machine those flats, because we want to subsequently come in with an additional flat bottom tool or a end mill to machine those flat regions. So again, I can choose the toolpath trimming functionality, choose the boundary, and go ahead simply and click on OK. Again, the toolpath gets trimmed. The leads and links for those particular trimmed areas gets recalculated, and my flat areas have been excluded from my steep and shallow strategy. This is super efficient from a programming point of view, from a machining point of view, and we can then come in with an additional flat toolpath to machine those flat areas off separately as a post-processing option. Lastly, I would like to touch on how we go about removing inefficiencies in some of our toolpaths. Now, here on screen, we've got a steep and shallow strategy to machine some of the vertical or the steeper regions, but also some of the shallower regions on this mold tool. Now, you can see some of those collisions here here, here, and here. And I can show you that the actual body of the part, or the holder of the tool, is actually colliding with the part. Okay, so let's have a look at now how we can go about minimizing some of these efficiencies. So I can simply use the trimming functionality, trim the part, and in this instance, I can keep both instances. What this is going to do is it's going to split the toolpath into two main segments. And there you can see those two segments on screen. Now, what I'd like to do is go and simulate this just to make sure that I can verify that all of my collisions are in one portion of the toolpath. So let's have a look at that from the top down. And there we can see the first portion of the toolpath doesn't have any collisions, whereas the second portion of the toolpath has all of those collisions in that we've just mentioned. Okay, so I'm not going to waste time showing you all of those collisions. But really, the important thing here is as we open up and extend these individual selections, we can see that there are tools associated to each of these sections. Now, for that second section, what we really want to do to eliminate some of these collisions is use a longer tool. So with this particular toolpath segment, I can come into the Modify section, change the tool, and go and select a longer tool. In this case, I'm going to select tool number 6, click on OK, and click on OK. And again, if we open up that toolpath segment here, the toolpath is not recalculated. This is critical to understand. There you can see toolpath, there you can see tool number 7, and then you can also see tool number 6 for those regions. Now, when we go and simulate this again, we can see that all of those collisions that we previously had have now been removed from the model, meaning we're making our programming more efficient, we're saving our tools, increasing tool life, but also more importantly, using the shortest and the most rigid tools for as much of the machining as possible. And then when required, we can switch over to a longer tool to make sure that we aren't getting any collisions on our part. Okay, so let's jump back to the presentation and kind of let's recap on what we've seen. We've seen how toolpath modifications can be a powerful tool to increase productivity and reduce your cycle times. We've seen how using model geometry can be used to trim a toolpath, whilst the trim remains associative to the model. We've also seen how trimming rogue segments of toolpath lead to more efficient toolpath segments, whilst the ability to remove air cutting reduces machining cycle times. We also got to see how trimming can be used on multiple toolpaths for various areas to ensure the best surface finish possible, whilst the ability to change tools for specific trimmed sections provides you with a peace of mind that the toolpath is being machined with the shortest, most rigid tool for the best possible surface finish. Okay, so some of the things we've seen today, we've kind of spoken a bit about me. We've kind of looked at the extensions as an overview. We've kind of taken that one level deeper and look at the machining extension and compared kind of core versus machining extension functionality. And then we've really taken a deep dive as quick as possible into toolpath modifications and why I think it's a single reason enough for you to upgrade. And right now, really, we're going to talk about how you can go about getting access to some of this goodness, really. And the link in the presentation, as you can see, and my colleague Dylan will endeavor to post this into the chat. And the bit to understand here is this kind of takes you to a web page where you can kind of fill in your details. And the beauty here is this actually connects you with someone who will get in contact with you and trying to understand what you do so that they can better recommend some of these products to you. You also get the opportunity to kind of discuss some of your requirements. So it's a real win-win here by going to sign up for this trial. And the trial is really 7 days, 7 days long. But you don't just get access to the toolpath optimization, you get access to on-machine verification, so probing functionality, you get access to multi-axis machining, like, for example, steep and shallow 3 and 5 axis multi-axis options, but you also get various programming automation tools as well. For those of you that don't necessarily want to type in that link, grab your phone, get the QR code out on the scanner on your phone. You can scan the link and it'll take you to exactly the same page as well. So with that, I'm going to thank you all for your time, and I'm going to quickly have a look at some of the chat and see some of the questions that have come in. So a great question that's come in is, do you see many customers really using toolpath edits? Absolutely. I mean, we kind of see a lot of our customers coming into contact with us privately and saying, we can't thank you enough for this. This is something that's been lacking hugely in Fusion 360, and we can't welcome it enough. It saves, for example, on that bracket with those lugs, it saved a number of our customers infinite amount of time and money, just being able to trim the unnecessary air machining sections on their parts. So yeah, extremely valuable for our customers. So currently all the trimming comes as a package as part of the machining extension. But as I said to you before, this is a question from Rob. The machining extension is bundled with a number of different things with it, and it's consumable in your own way, whether it's a daily, whether it's a monthly, or whether it's an annual option, you decide. How they're purchased is slightly differently. For the day. For the day version, you use cloud credits currently. However, for monthly and annually, those are either purchased via your credit card, via your account. But yeah, there's loads of ways for you to consume these in your own way. Yeah, to answer Rob's question, really, is that the trimming really comes as a package of the machining extension along with a lot of other things. It's not just on its own. So you get a lot more benefit, a lot more power as well. Okay, so we're kind of 21 minutes in. Is there any other questions from anyone? Just having a look at the chat there. What I will do is I will stay online anyway to kind of answer any questions, but I'd like to thank you all for your time, and thanks for joining this webinar, and have yourselves a lovely day. Thanks very much.